Hello everyone and welcome back to our channel Quaint. We have seen the title Optical Vortex Beams, the photons hidden angular momentum. So you can see the term hidden is there in the title. So what is the reason of that term hidden? You know, photons or the light carries angular momentum. But why the term hidden is there? So reason behind is that actually light carries two types of angular momentum. One is called spin angular momentum, another one is called orbital angular momentum. And orbital angular momentum, or in short this is called OAM, this you cannot see in normal cases. Yes, if you use a laser beam, in that case, if you use a normal laser beam, in that case you cannot find that OAM, that is orbital angular momentum. Only if you twist some way that laser beam, then only you can see. You need to do what? You need to twist that laser beam. You need to twist that normal laser beam. Then only you can see that OAM, that is orbital angular momentum. Twisting of light has been done some way. So twisting has become possible. That means in that case the photon particles in that beam carries a special type of angular momentum known as orbital angular momentum. And since those angular momentum, means I am talking about that orbital angular momentum, are not visible in normal cases, that's why the term hidden is there in the title. Means you can say this way that photon particles or photons secretly carry hidden angular momentum. Anyway, these two types of momentums are different. Spin angular momentum, you know that left and right circular, that is actually related to polarization. And this OAM, this is related to what? This is related to the shape of the wavefront. Okay, shape and phase of the wavefront. Anyway, in normal cases, you cannot see this thing. Twisting is required, and scientists use many devices like Q plates, okay, then special phase plates, then computer generated holograms, then special light modulators. So scientists use these different types of devices to imprint a phase shift, not shift, to imprint a phase twist onto the laser beam, so that normal or the ordinary laser beam becomes a vortex. Means you can see a vortex structure. Okay, vortex structure means what? Means it looks like a donut. At the center you can find a dark space. That is actually due to phase singularity. Light intensity becomes zero at the center. So that is dark zone. Okay, so that is actually called phase singularity. And around this you can find a bright ring, spiral, which is actually spiraling. Okay. So that is what? That is the vortex beam. That is the vortex beam. So this is called optical vortex beam. Okay. Looks like a donut. The core region, the center core region, that is actually dark due to phase singularity. And outside you can see a bright ring, spiraling bright ring. Okay, and that is due to what? Why spiraling? Because that OAM is present. Anyway, so we were talking about OAM. In case of qubits, only two basis states are there, Ket0 and Ket1. But if you increase the number of twists per wavelength, and if it say for example the number of states per wavelength is 3, 4 or more than that, then in that case that becomes actually qudit. Whenever it crosses, number of states per wavelength crosses 2, that means it becomes 3, 4 or beyond that, then in that case this becomes actually qudit. And you know qudit-based computing. Here what happens actually, photon particles can can store more information than qubits, because a qubit, what are the basis states? Only 0 and 1. But in case of qudits, there is no upper limit here. Okay, it is denoted by D, and actually small letter L is used, which is called topological charge. So what are the basis states here? Here basis states are what? Ket 0, Ket plus Ket 1, sorry, not plus, Ket 0, Ket 1, Ket 2, Ket 3, like that. These are the basis states. Anyway, so here so many limitless basis states are there. Better to say limitless states are there. Again, superpositions between them, that is also present, because this qudit or the photon OAM, okay, orbital angular momentum, photon orbital angular momentum allows multiple states, actually better to say more than 2 states. There is no upper limit, as well as superposition. These two things are allowed by photon OAM. That's why this becomes qudit. And whenever you are dealing with qudit, that means what? That means more information per particle, larger Hilbert space, computational power increases exponentially. Fewer resources are required, that means fewer particles are required. And we are talking about photons, that means fewer photons are required. And these are very useful. Qudit-based computing is very useful in case of plasma physics, in case of molecular chemistry, means molecular interactions can be computed easily using qudit-based computing systems, qudit-based quantum computing systems. Okay, and different universities and labs are already encoding messages using this special property of photon. So that way actually high dimensional cryptography has become possible. Universities and labs are already doing this thing. So that is useful for what? Quantum communication. Again, in case of quantum computing, this is the requirement. More states per particle, that is the requirement. Actually, qudit-based quantum computing, that is the requirement, and that has become possible due to this. Though other types of qudits are also available, like trapped ion qudits, those are available. Then defects in crystal, okay, that thing also can be used. Again, superconducting circuits, that thing also can be used to produce qudits. And those qudits are used in a quantum computing system, and those things are called actually qudit-based quantum computing. Okay. Again, in case of biology, you know, this optical vortex beams, that this can physically rotate microscopic particles. So, enabling optical tweezers used in biology. Again, in case of astronomy, telescopes use this special property, wave of photon, okay, to do what? To filter out starlight and observe planets. Whenever you are using telescope to observe distant planets, in that case starlights actually create troubles. So you need to filter out that starlight. Okay, then only the planets become clearly visible. So to filter out that starlight, this special property of light is used, wave. But don't think that photon particles actually spin like a ball. No. Actually, its wavefront carries a helical structure. And since helical structure is present, that's why wave is present. But photon particles are not spinning like ball. Anyway, now you know that actually light has 2 types of angular momentum. One is a spin angular momentum, that is always present in any case, in any situation. That is normally present, that remains normally present. Optical angular momentum, spin angular momentum. And orbital angular momentum, this is special case. This you need to produce by twisting the light. You need to twist the light. Okay, that means actually you take a laser beam and you imprint phase twist onto that beam by using different devices, like I have already mentioned those devices. Okay. Anyway, so what? That means if you can increase the number of states, So you can store more information. So to do that, what you need to do? You need to twist more and more and more. That way you can increase the number of available states, quantum states. And if number of quantum states are more, then you can store more information per particle. That is the advantage of using Qudit, of using this photon OAM. You need to do what? You need to increase the phase twist. Means better to say only twist. You need to increase the twist. Okay, that means computational power increases, or better to say computational power scales with L. L is topological charge. Okay, means which varies from actually 0, 1, 2, 3, 4, like that. Anyway, so this was all about today's topic. Okay, optical vortex beams. So now you know the reason why hidden that term was present in the title, because normally this is not seen. Anyway, so this is the end of this video. If you found this video interesting, so please like, share and subscribe to our channel. This is the end. Thanks for watching.